grade 12s and welcome to Life Science. And today we're going to have a look at the revision of the endocrine system and homeostasis. Right, so all the stuff that we've done before, we need to have a look at it because of course exams are coming up. So let's have a look what we've got. Okay, first of all, when we study this endocrine system and homeostasis, you've got to remember what homeostasis is, right? And that's a balance in the body, right? And can you remember that you've got two different systems that control it? Okay, you've got your nervous system and then you've got the hormones. Okay, so we're going to look at the hormones and how they control everything. Okay, now, best way to do this, I think, is through questions. So you are going to be doing questions that it comes out of your ears, right? So I want you to concentrate, have a look what I've got for you, and give me the best answers, right? So let's have a look. First question that we have here. The diagram below shows the interaction of two hormones in controlling blood sugar levels. Right, so the first thing we're going to have a look at is the blood and the sugar levels. Okay, so the diagram we have here, I haven't even looked at the question. We've got two organs, right? Organ A and organ B. Okay, and if we have a look at organ A, you'll notice that all the arrows are moving towards it. Okay, and you've got hormone levels increased to the high blood glucose levels, and you've got hormone levels increased due to low blood glucose levels, and then you've got organ B. Okay, so let's have a look at what the question is. The question is, identify organs A and B. All I want you to do is give me what A and B is, right? And I'm going to give you a quick minute to do that. Make sure you concentrate and know exactly what's spotting. Look at the diagram carefully. Are you ready? Off you go. Okay, so now, if we have a look at this, there's definitely two hormones we've got to have a look at. I mean, two organs we're going to have a look at. And we need to know which one is which, right? And the two organs that we know is going to be involved in this is, of course, your pancreas and your liver. Okay, so we're going to look at the islets of Langerhans, and they're most going to secrete glucagon and insulin, right? So that's what we're going to have a look at. Okay, so let's have a look. Which one's which? Which one picks up the message and which one delivers the hormones? Okay, so if we have a look at it, the liver is A, okay? The liver is A, and B is your pancreas. Remember, in your pancreas, you're going to find the two types of cells, alpha and beta cells in the islets of Langerhans, and alpha cells do glucagon and beta cells does insulin. Remember that. Okay, now let's go to the next question. Same thing, same glucose level, everything. So let's see what else is. Which two hormones is secreted when the blood levels of glucose in the blood? Okay, so now I don't need the diagram anymore. This is what we're looking at. Okay, so which hormones is secreted when the levels of glucose in the blood increase and B, decrease? So you need to know which one does what. Okay, 1 minute, let's see if you can get them right. Make sure you concentrate. There's specific ones for specific things. Are you ready? Off you go. Now, remember, there's two hormones that we're looking at, okay? The first one, of course, is, if we look at it, when the increase in glucose, okay, we need to secrete or we need to let go of insulin because insulin helps the muscles and everything absorb glucose, okay, and change it into glycogen, right? And once that's happened, if there's too little glucose in the body, what happens? So the decrease in glucose, what do we produce? We produce glucagon, and glucagon helps change the glycogen back into glucose so that your body can handle it. Nice. So I know you guys are getting this right because you know what's going on. Okay, sticking with the same question, this whole thing, as I said, has just got questions in it all the time. So here we go. Which one of the organs, A or B, monitors the concentration of glucose in the blood? In the blood, not in the blood. In the blood. Which one, A or B? Which one of the organs monitors how much glucose or the concentration of glucose is in the blood? 1 minute. Are you ready? Off you go. Okay, which organ monitors the concentration of glucose in the blood? And of course, we know it is organ number B. Okay, the reason why it's organ number B, what was B? Can you remember? Okay, B was, think about it carefully, B is your liver. Okay, so all of this, if we have a look at it, the liver picks it up. There we go. And the organ that it tells it, if that thing is low, you need to secrete from the pancreas, islets of Langerhans and all of that. Right. Okay. Next one. New question. Of course, we have more than just one set of hormones that work out homeostasis. Remember the balance in the body. Okay. And this one's quite cool. Okay. The diagram A and B represents a longitudinal section of the human skin that is exposed to different environmental temperatures. Now let's have a look at these two. Okay, that's quite cool. Now, you can see there's blood vessels involved, and there's some tube-like structure there, okay? And we know it's skin. So that tube-like structure's got to be a specific thing, okay? So let's have a look what the question is. Which diagram, A or B, is exposed to warm environmental conditions? Okay, which one, A or B, has got to do with warm environmental conditions? Okay, 1 minute. Are you ready? Off you go. Okay, now to me, this was quite an easy question, okay? The reason why it was an easy question is I'm using my visual, okay, my vision to actually see what is going on. And if I have a look at this very, very carefully, and I'm just looking at one specific thing, okay, if I have a look at that, okay, remember this is the skin. To me, that could either be heat, which you don't ever give off steam. So what do you give off? You give off perspiration, okay? So let's have a look at what the answer was. The answer was number A, okay? This one here is the one that's got warm temperatures, okay? Now, the question that I've got for you, the next one, is very similar. It's the linking on of this question. And here we go. It says, provide two observations, two observable reasons for your answer in the previous question. So two observable answers to the previous question. And think about it carefully. Observable means you need to be able to physically see it. I don't want you to think of other things. I want you to look at the diagram and tell me exactly what it is that you see that actually gives you the correct answer. Okay, I'm going to give you a minute again. Are you ready? Off you go. Okay, so now, visible reasons. The question was, give two visible reasons why you would choose A as the one that has been produced or in a warmer temperature. So let's have a good look at this A. First of all, the first time we did it, I circled that thing, okay? Now, that is very simple. That's perspiration. So that means we have the ducts coming out and cooling your skin. Remember, perspiration goes over the skin and it cools it down. That's the first thing. The second thing that to me is very, very obvious, and they've labeled it for you. Okay, here we go. Have a look at the blood vessels. Look at the difference in the two sets of blood vessels. The one in diagram A, you'll notice how dark and how big they are. And in blood vessel B, they're a lot smaller, okay? That tells you something, okay? That tells you exactly the difference. First of all, the first one, dilated superficial blood vessels, and then the secretion of sweat from the sweat glands. Remember, dilation means it comes out. You will notice on a hot day that sometimes your arms are full of veins and arteries and you can see them all. That's because they've come up to the surface so that when the wind blows across them, they're actually going to cool off. Okay, that's the main reason. So water goes on, as it evaporates, it cools it down, and as the wind blows over it, it cools the blood down. So the blood is cooled by the skin as well. It's quite cool, hey? Now, another question. Let's have a look what we've got here. Okay, name the parts of the brain that monitors the blood temperature. Name the part of the brain that monitors the blood temperature. And you know what? I'm going to give you another minute to do this, okay? But I want you to concentrate, because remember, there's lots of part of the brain, and the brain's very important. There's so many sections in the brain that you had to learn when we had to do the nervous system. So you should know it still quite well, okay? So 1 minute. Are you ready? Off you go. Okay, so let's have a look at your answer. Now, first of all, there's different regions of the brain that's very important, but the main one we're having a look at for, this is the one that's going to pick up the sense of how hot you are or how cool you need to be or how hot you are. As I said, hot and cold, it gives you the temperature. And the part of the brain that we're having a look at that's very special here is called your hypothalamus. Your hypothalamus controls a lot of different things, but one of the big things it does control is temperature. And remember, we are warm-blooded, so our temperature inside doesn't work with the atmosphere on the outside. It's got to stay at a certain temperature. Right, so after going through so many questions already, okay, I reckon you need a break because I need a break, and I'll see you straight afterwards. Cheers. Welcome back. Now, we left off with the skin, and we're talking about temperature, and we remember that inside the brain, the hypothalamus controls the heat, and we were looking at how superficial veins came out and the sweat glands were there. Those were the last things we did. So we're going to stick to the same diagram, okay? So everything's still the same, and I'm going to add another question in. Let's have a look at the next question. Here it is. Explain how sweat glands will function to regulate the body's temperature after drinking a hot drink. Now, this is quite a big one, okay? How does it do that? How does it regulate the body, okay? And I'm going to give you 3 minutes for this one because I want you to think it through very carefully because there's different things that you've got to take into consideration with this, okay? So 3 minutes. Are you ready? Off you go. Okay, so let's have a look at this. Question again was, explain how sweat glands will function to regulate the body's temperature after drinking a hot drink. Now, What do you think? First of all, the key words there I'm looking at is hot drink, okay? You need to have a look at hot drink. So what does the hot drink actually do? Okay, so now, here we go. The consumption of a hot drink raises the body's temperature. Remember, it's going to go inside. Yes, it's not going into your cells, but it is. It's getting hot, okay? So it's warming everything up. Once that thing starts warming up, this activates the sweat glands. Why does it do that? Because the blood vessels that are absorbing the hot drink gets hot, right? So the blood itself warms up. So what does the blood need to do? It starts cooling off. So how do we do that? More sweat is secreted. Remember, the more, I'd say, the more the body increases in heat on the inside, we need to get rid of it, right? How do we get rid of it? Send the blood to the surface. When the blood's at the surface, we need to cool it down by putting sweat glands over it so that all that heat can evaporate. And then last one, excess sweat evaporates and cools down the body. So that's roundabout what we were looking for, right? And I know you got that answer, so I'm not that stressed. Okay, but now, let's have a look at the next things. And let's change it a bit. Let's get a little bit more complicated. Okay, here's the next question. Have a look at this. Describe how human body restores the carbon dioxide concentration in the blood when it raises above normal levels. Now, I'm not going to give you a clue about this. I want you to have a look at that question, right? And I want you to answer it to the best of your abilities. Okay, so concentrate. I'm going to give you 3 minutes on this one because this is a long one. You're going to have to concentrate and give me everything you've got. Are you ready? Off you go. Okay, now let's have a look at that answer. Before I even show you the answer, let's have a look at this question properly. Okay, first of all, we're having a look at carbon dioxide, okay, and when it is risen, or when it becomes higher than normal, okay, how do we restore the carbon dioxide concentration in the blood if it goes higher than normal? Please understand that there has to be carbon dioxide in the blood. Okay, if there's too little carbon dioxide in the blood, means you've breathed out too much carbon dioxide, you got this thing called hyperventilation. And that's why people breathe into a brown paper bag. What happens is you breathe out carbon dioxide and you breathe back in carbon dioxide. Because if there's not enough carbon dioxide, you're not going to get that changing over from carbon dioxide to oxygen. It's very, very important to make sure that you have carbon dioxide. Okay, now, how are we going to rise it? Don't look at the board yet. Don't look at me. How are we going to rise our carbon dioxide levels? Remember, the minute you start doing exercises, the byproduct of burning glucose is carbon dioxide, right? And remember, carbon dioxide is actually acidic, right? And the minute carbon dioxide goes into your bloodstream, it becomes a little bit more acidic. And because your blood becomes acidic, that's the key thing. Now we need to have a look at how we're going to restore the acidity back to its normal self. Okay, so what do we look at? First of all, let's go back down here. Receptor cells in the choroid artery, the choroid artery, which is aorta, are stimulated to send impulses to the medulla oblongata. Remember, that's in the brain. That's a part of the brain. The medulla oblongata in the brain. Okay, this stimulates the heart to beat faster. Why would it stimulate the heart to beat faster? Remember, if there's lots of carbon dioxide in the blood, we want to get rid of it as quick as possible. So we need to take all the blood to the lungs. That's what we want to do, as quick as possible. Okay, and the breathing muscles to contract more actively. So in other words, you've got these muscles. First of all, you've got this bottom one, which is called your diaphragm. Remember, that goes up and down. And then you've got these muscles between your ribs. They're called intercostal muscles. And they make your ribs move out and back and forth. Okay, so if we have a look at it, just by doing or controlling the amount or the rhythm of the breathing, making those muscles move in and out, you'll notice it increases the rate and depth of breathing. That's why you take deep breaths all the time. Okay, and that when it does that and it expands and the heart starts pumping faster, what do? You breathe in a lot of oxygen. And if you breathe in a lot of oxygen, they swap over and you breathe out a lot of carbon dioxide. And that is why, if we have a look, it says and exhale, you inhale, take more carbon dioxide out into the air, and you inhale or take in oxygen all over again. Now, you must understand that balance is very, very, very important, okay? Because we don't want our blood too acidic. The oxygen levels must come in and the carbon dioxide levels must come out. And that is the main reason why, if you run, for example, the 100-meter sprints, you don't go on your marks, get set, go, and as you start running, you breathe heavily. It's not like that. We try and breathe, we control it until we finish past the finish line. But have you noticed when we pass the finish line, we don't just go and then stop. No, we carry on breathing fast for a longer period of time. Why do we do that? So that we can replace all the carbon dioxide, get rid of it, and replace oxygen back into the blood. That's one of the big things that you must remember. Okay, now that is just we spoke about blood glucose levels, we've spoken about the heat, and now we've just spoken about what was I thinking about? Let's go back, let's have a look. We were having a look at the carbon dioxide in the body. Now that is called your negative feedback mechanism. Okay, your negative feedback. As one thing happens, another thing increases. As that thing happens, then another one. So they work in kaleidoscope with each other. So they move all the time. Right, now, this is a nice one. This is just a question. There's no question yet. I'm giving you a scenario. Right, so let's have a look at the scenario. First of all, in this investigation, we conduct a compared glucose concentration in blood of two people. Okay, Moy and Tabiso, right? There they are. Those two boys, we're going to look at their concentration of glucose levels before and after ingesting glucose. So we're going to look at what it is, then we're going to drink some glucose, and then we're going to monitor what happens. Okay, so here we go. The following process was followed. Now remember, if it's an investigation, there's certain things that have to be kept the same. You've got to make sure that everything is identical for both boys so that there's no mistakes. Okay, so here we go. The glucose concentration in their blood was measured at the start of the investigation and again 1 hour into the investigation. So at the start and then an hour into the investigation. Okay, then 1 hour into the investigation, each of them was given 50 milliliters of glucose solution to drink. So now we're forcing glucose into their body. Okay, once we did that, for the next 4 hours after ingesting glucose solution, the glucose concentration in their body was measured every 30 minutes. So now we're looking at 30 minutes all the time. Every 30 minutes, you got to measure it again. Okay, and we ended off with this. The arrows indicate when they drank the glucose solution, not the normal glucose concentration in the blood. The normal concentrations in the blood was between 80 and 120 milligrams per 100 centimeters cubed. So there we go. That's just the thing that we're having a look at. Remember, there's Moy and there's Tabiso, right? And we're going to figure out what their blood glucose levels are, where they were, and what is going on. Right, but I showed you that so that we could understand it and get everything before we go on to a break. So when you come back, you remember what is going on. I'm testing that memory, so make sure you concentrate. Go have a break, let it flow. When you come back, you need to concentrate because I'm not going back to tell you about Moyo and Sipo. Sipo, checking me. Okay, we're going to make sure that we can answer the questions on the specific graphs that we've got. Right, so go and enjoy your quick break. When you get back, we're going to carry on straight with these questions. See you straight afterwards. Welcome back. Now remember, we're going straight into the questions. And remember, I said I'm not going to repeat what I said about those two boys and the glucose. So let's go straight into it. We have the specific thing going here. And this is the question of this graph. It says, provide a suitable title for this graph. Provide a suitable title for the graph. Okay? And I'm going to give you 2 minutes because I want you to add on to that. I want you to provide a suitable title for the graph, and I want to know why you chose that title. Okay, so the main one is why I'll give a title to the graph, and then a sub thing here, just on the corner, which means you're going to talk about is why you chose that title. Okay, so it's 2 minutes. Are you ready? Off you go. Okay, so here we go. I wanted to know the title of this graph. Now, I've put the title in here, okay, but I've also left something out. Let's see if you can pick it up, okay? The title that I would have put for this graph, here it is, very simple. It is the comparison of blood glucose level of 2 people over 5 hours before and after ingesting glucose. Okay, now, that's roundabout right. Now, one part I am missing. The part that I'm missing here, it says the comparison of blood glucose levels, and over here, you need to put in milligrams per 100 centimeters cube of 2 people. Okay, I left it out for a reason. Okay, one thing that you guys always forget is to explain or show exactly what we're measuring. Okay, if you have a look at this, we're showing, let me just make it a nice M, we're showing milligrams per 100 meters cubed, and we're showing hours. Okay, why would that be an appropriate title? Okay, the main reason is it is using both axes. In a title, both your axes have to be inside the title. So the two things is blood glucose concentration, blood glucose levels in milligrams, and time in hours. And then before and after, we've given them glucose. Okay, so that is, you got to make sure that everything works out perfectly. Okay, now, next question, same graph, nothing's changed. It says, by how much did Tabiso's blood glucose concentration levels increase in milligrams per 100 meters cubed after drinking the glucose solution? Show all your working out. How much did it increase? And this is where we look at, no, I'm not going to give it to you. Okay, I'm going to give you 2 minutes. I'm not even going to give you any more clues. Remember, I'm going to move it to there so that, well, maybe a little bit more. There we go. Okay, and let's see. Well, you know what? I can actually move it a little bit more because the question is there. And remember, show all working outs at the bottom. So I'm going to give you 2 minutes. Are you ready? Off you go. Okay, so yes, there is maths involved here. Okay, so let's have a look at it. First of all, we need to know how much did it increase to. Remember, it said, I'm just going to bring it down a little bit. Okay, it says there, by how much did Tabiso's blood glucose concentration levels increase. It didn't tell you about which levels or whatever, but of course, we need to make sure we look at the top one, okay, and we have a look how much it increased, and that's its max, okay, and we started at the line there, okay, so let's have a look. The best way to work it out, okay, if you take 145, okay, and 145 is what his max was, okay, so this is going up in tens and it was halfway, so it's 145, you minus 125, because that's what you began with. So you take 145, you minus 125, and you're going to end up with 20 milligrams per centimeter cubed. Okay, that is your answer. Make sure that you've given everything, because they're going to check. They most probably will mark all three of them. So concentrate when you get a question, especially when they tell you, show all working out. Okay, next question, still the same. How long did it take Moyo's blood glucose concentration to return to its original after ingesting glucose concentration? So how long, how much period do you think it would have taken him for his things to go back to normal? I'm going to give you 1 minute. Let's see if you can work that out. Are you ready? Off you go. I think I caught you. Okay, let's have a look at this. Now, we're looking at the period. Let me pull this up here. Well, how long it took for his glucose levels to get back to its original amount. And of course, that is period X. Okay, what's the original amount? So let's have a look. The beginning is round about there, and this one is round about there. And if I work that out carefully, the distance from 3 to there is about 1.7, 1.9. Okay, so that is what we're looking at. And it's going to be to about 1.7 to 1.9 hours. So 1 hour and 42 minutes to 1 hour and 54 minutes. Round about, give and take. Okay, so they'll look between, they're going to take that, 1 hour and 42 minus 1 hour and 54. It's round about there. Okay, that's the main what that we're looking at. Okay, now, next question. We always go to the next one. Who has diabetes mellitus? There we go, diabetes mellitus. And give one observation reason for your answer. So who has it and why would you say that? Okay, that means I'm going to give you 2 minutes to do that. Let's see if you can get it right. Are you ready? Off you go. Okay, so let's have a look what we end up with. Okay, very simple. The nicest way of looking at it is you need to look at who starts and where they start and how their body reacts to whatever we're doing here. Okay, so we're having a look at glucose level. And first thing we're going to have a look at is the heights. Okay, so the minute the one is higher than the other, we know that Tabiso has more chance of having the diabetes. So of course, it is Tabiso who has diabetes mellitus. Okay, so he has it. And why would you say that? Exactly like I said. First of all, he starts off, his glucose levels are a lot higher. His glucose levels are a lot higher than the normal range. That's the first one. The second thing is it takes longer for his glucose levels to come down to its original level. So that's the whole point. Okay, there are the two facts. You can see it on the paper, so everything is fine. Right, so hopefully you enjoyed that, right? I know you guys got those answers and I know those brains are working, and I will see you soon. Until next time, cheers.